which will be a real valued curve, and it is basically going to help us find out the actual output, right? So in linear regression, we try to draw a line, and we gave a equation of line as y equals to mx plus c, and we actually formulated it as a hypothesis function. So hypothesis function is h x is equals to theta 0 of x plus theta 1. So this is basically our hypothesis function, and we said that if I will have the perfect value of theta 1 parameters, then I will be able to get a line which will give me the output, right? So we defined the cost function. We have not defined it yet. We will define the cost function, and cost function will be represented as j of theta 0 comma theta 1. So in cost function, we say that given these two parameters, theta 0 and theta 1, we will try to find out the cost. So let's see what that means. So first of all, I would like to draw a graph. In this graph, we are actually going to take the previous example of area versus price graph. So we have area in square feet and we have the price. So we will plot the data points. So I'm going to plot it randomly here. Right, so we want to plot the we're going to plot these data points, which actually are the which we have actually seen in the data set. So now we want to plot the hypothesis function, and we want the perfect pair of theta 0 and theta 1. So now let's suppose there is a person, and let's say he's person A, and what person A does, he says that I think that this line, this one which I'm going to draw here, according to him, he says this one is the best fit. So it means that in order to draw this line, he might have chosen theta 0 and theta 1, which are nothing but slope and intercept. So he might have chosen some intercept from here, and he also have used some theta 0 value. So I'm going to write here he used some theta 0 comma theta 1 pair to draw this line, and this is by person A. So there is another person, and he claims that I think that this line, this one, according to him, person B, he says this one is the best fit, and also he has chosen some theta 0 and theta 1 parameters in order to draw this line. Now from this graph, we can actually say that B, the person B, is giving us a solution which is far better than A, because the line B is actually passing through most of the data points and is best fitting our data points. So I can actually determine from this equation that B is better than A, right? We can compare these two lines. But what will happen if there is a person who says, now there is another person, and he claims that this line, which is in green color, this one, so now there is a person here, let's say this is by C. Now this person claims that this is the best fit when chosen some values of theta 0 and theta 1. So you can choose theta 0 and theta 1 anything, and you will be able to obtain any line on this graph. So now, which is better? Is B best fit for our data set or C? Now in this case, we are not able to determine that. So we need some metric or some measure to find out which one is better. And that is why we have introduced cost function. So what cost function does, when you have picked up a value of theta 0 and theta 1, like we have done in these three cases, this function will output a cost. It will output a cost in each of these cases. Now we can use this cost to compare all of these cases. So if the cost is minimum, so the A will have some cost, B will also have some cost, C is also having some cost, and we can actually we can compare all these three costs, and out of these the minimum one, whatever will be the minimum, we are going to just say that this is the best pair, and then we will input these two theta 0 and theta 1 in here, and we will say that this is the best fit line, and so the problem will be solved. So the first question is how to find that cost. What is the cost function? So now the cost function has a mathematical formula. In short, the mathematical formula is known as the mean squared distance. Mean squared distance. So what is mean squared distance? Let's see what exactly it is. So let's suppose we have a graph again here, and I will try to again draw some data points randomly. And now let's suppose we have a line, this, and obviously I have chosen some pair of theta 0 comma theta 1 to plot this line. Now the mean square distance says that in order to find the cost when considering a pair, what you have to do is you will have to find out, first you will have to find out the distance from this point. You can see that this point has a projection on this axis, so this is our area. So let's suppose this is exactly, let's say 400. So this is x is 0, so 0 comma 400 is this point. And if you see it here on the y-axis, which is the price, let's say it has a value 3000. This is actually the price. So this point basically represents that when area is 400 square feet, we have the price 3000 or 3000 comma 0, right? So what we try to do is we try to find distance from this point and to the distance of the line of this line, and this line is nothing but our hypothesis. So let's suppose there is a point here. Now we will try to find the distance between the actual point and the predicted value. So this point is actually the prediction, right? So I'm going to say that this is a predicted value, and this point is the actual point or the actual value. Now this distance can be calculated like this. What you just need to do is just find the projection. Now for this hypothesis function, there will be some value. I'm going to say it is xi comma yi, and since this is the hypothesis function, I am going to just write cap on them so that we will be able to know that this is actually of the predicted value, not the actual value. Now here we have a projection, and this is of the actual value, so I'm going to write xi comma yi. So on the y-axis we have yi cap, and for the actual value we have yi, and yi is nothing but h of x. Then you are considering the parameters, you write theta in front of x, right? So you write theta because the parameters are theta here. So now what we just do is we want to find the distance, and the distance is of the difference between h theta x and yi. So this is actually a little bit complex, but this is how we actually calculate the distance. We try to find out the projection yi cap, which is nothing but our h theta x. This is yi cap. Then you have considered theta 0 and theta 1 here, and then you have yi, which is the actual data point. So what you have to do is you will have to subtract h theta x minus yi. So this is the distance. Now if you try to calculate the same from this point to this one, you will find out that the value of h theta x will be greater than yi. So in that case we will get a positive distance, but in this case you will get a negative distance. So that's why we are doing squares. So that's why we do the squares, so that we don't want negative distances. Now we know what is squared and what is distance. So this is the squared distance, but after calculating all the distances from all the points to the hypothesis line, we will add them up, right? We will add them up. So I'm going to write summation here, and it will go from I equals to 1, which is this point. Let's say this is the first point. So it will go from I equals to 1, and let's suppose there are m points, right? So it will go from I equals to 1 till m. So this is how you calculate the values of theta 0 and theta 1. This is how you calculate the squared distance. Now when you will add all of them, all these distances, when you will try to add them up and you are also squaring this, now this will give you a very huge value. And since we will plot the cost function on the graph, the plotting will become difficult. So what we do is we divide it by by m. So that's why we say that it is a mean, because we are actually adding whole distances, whole square distances, and then we are taking the mean, which is 1 by m. And now I can easily plot the cost function. So this is known as intuition. This is the cost function intuition. And I hope this concept, that why we are actually taking the difference of h theta x and yi, is clear. So when you are considering theta 0 and theta 1 here, you will be able to get a cost using this formula. And similarly, if you have some other line, let's suppose you have some other line which is, let's say, like this. Now what you will have to do is you will again find out the distances like this from all the points, actual points to this. So for some other values of theta 0, theta 1, and then you are again going to put the values here and calculate the sum. You will get the cost. So for each pair of theta 0, theta 1, or for each hypothesis function, I can calculate the cost. If I can calculate the cost, I will just have to find the minimum value of the cost, and that will basically help me in understanding and finding the best hypothesis function or the best fit for our dataset. Right? So let's try to do an example on cost function. Right? So we are going to do an example on cost function. A very simple example. So first of all, I will draw a graph here, and since the matrix will be very useful. I'm going to just draw it something like this, and from here to here. Right, so now we're going to take the actual values of these data points, not some random values. So let me mark 1, and this will be 2, and this will be 3, and similarly this will be 1, this will be 2, and this will be 3. And now I'm going to mark some points on this data set. I'm going to mark some points on the data set. Let's consider this point, which is 1 comma 1, then 2 comma 2, and then finally 3 comma 3. So these points are have come from our data set, right? So 1 1 2 2 is in our data set, and it will be having some labels. Let's say the label is label X and label Y. So I'm not going to write a label X, Y. You can actually just find it out from there. All right, so we have a graph now here, and these are the points, data points. Now what we are going to do is we are going to assume some values of theta 0 and theta 1 pair, and then we will find the cost function using the formula. So let's take our first case. In first case, I'm going to take theta 0 as, let's say, 0.5. So it means that the slope is 0.5. Let's take theta 1 as 0 because we don't want any intercept right now, right? So if theta 0 is 0.5, theta 1 is 0, what will be our hypothesis function? Theta 0 means 0.5x plus 0. So it will be equal to 0.5x. So if I will put 1 in x, I will get 0.5. If I will put 2, I will get 1. If I will put 3, I will get 1.5. So let's plot these points, and then we will be able to get a line. So this is 0.5, this will be 1, and then we have 1.5, so it will be here. So now what I'm going to do is I'm going to draw a line which will pass through all these points, right? Something like this. So I've taken some values of theta 0 and theta 1 as 0 and 0.5, and so this is, according to us, this is our hypothesis function h of x. Now what we are going to do is we have to find the squared distance, right? So what we are going to do is we are going to put it in this formula, the cost function formula, to find out the cost when we have this h of x. So what will be the cost? You can see here the distance will go from here to here, from this point to this point, and this point to this point. So easily, because this is a graph, we can find out these distances. So what are these distances? You can see this distance will be what? 1 minus 0.5. So h of theta x, yi. So if I is equals to 1, which will be this case, we have h of theta x as 0.5 minus 1 square, 1 by m. How many points are there? We have 3 points, so 1 by 3. And then we are going to take another value, live chat. Alright, so one important thing about live chat is that after the end of this video, I will be taking the live chat, and So if you have any doubts or anything you want to ask, you can actually do the live chat. I will be taking all the questions in the live chat, right? So because I do not want to break the flow of this whole tutorial. So let's start now where we have left off, right here. So this is for our first data point. Now let's consider the second one. For the second one, we have 1 and 2. So the distance will calculate it as 2 minus 1 square. Sorry, 1 minus 2 square, right? Because this point has a value 1 here and this has 2 here. So 1 minus 2 square plus, what is the final value? It is 1.5 and 3. So 1.5 minus 3 square. This is the minimum or the mean square distance, right? So for this particular case, when we are considering theta 0 as 0.5 and theta 1 as 0, we have this cost function. One important thing about cost function is that since we are going to write an algorithm to find the best cost out of all the cost, we will use derivative. We will try to derivate this cost function. And since it has square on that, the derivative will make this 2 come here. And since the 2 will come here, then again in the graph it will be difficult for us to plot such a slope because derivative gives us a slope. So in the cost function we divide it by 2. Now see, dividing it by 2m does not it changes the cost, but it does not mean that cost is changed for particular case. For all the cost it will change. And since cost is just a comparison value, it does not matter if we divide it by 2m or not. So here I'm going to multiply it by 2. So what will be the answer here? 1 by 6, then this is 0.5 square, and I have already calculated this answer. This will actually give us 0.58, right? So 0.58 is the cost when we are considering theta 0 as 0.5 and theta 1 as 0. So now let's consider an ideal case. An ideal case. Now in the ideal case, we're going to write an hypothesis function that will pass through all the actual data points. So in that case, we are going to assume theta 0 and theta 1. So I will assume theta 0 as 1 and theta 1 as 0. So the slope is 1. So if I will try to draw a graph with these values, I know h of x will be theta 0 of x plus theta 1, which will give me x. So h of x equals to x will give me points 1 comma 1, 2 comma 2, 3 comma 3. Now observe that if I try to draw a hypothesis function, let me just change the color for the ideal case. Let's say green. So now we are going to draw a line here. Now this is the ideal case. This one is our ideal case. Why? Because in this case, the hypothesis function or the line is passing through all the data points. Now, since it is passing through all the data points, it is best fitting our data. So now let's see what will be the cost in this case, in the ideal case. So in the ideal case, we are going to again find the difference of this and this. You will observe that the cost, when you will apply this formula, this calculation, it will be 0. Why? Because this will give me 0, 1 minus 1 is 0, this will give me 0, this will give me 0. So 0 plus 0, 0. It's all 0. So what is the cost in the ideal case? In the ideal case, the cost is 0. And in this case, you can see the cost is 0.58. So if someone asks you out of this line and this line, which one is a better one? So then you can say, oh, I have calculated the cost, and the cost is minimum in this case. So obviously this case is better. So I'm going to use this case. In this case, the value of theta 0 is 1 and theta 1 is equals to 0, and the function is hx equals to x. So that's how we try to find out the value, or try to find out the best fit for a dataset. That's the whole work. So now we know how to calculate the cost. Now there are only two cases in this. We have only considered two cases. One of them was ideal. So it is easier to calculate the minimum of them. It's easier to find the minimum of all these courses, of all these costs. Now what will happen is we have different theta 0 and theta 1 value, because we have a range of these pairs, theta 0, theta 1. So there will be different lines, right? So there can be a line like this, or this, or this, because there are various theta 0 and theta 1s. So how will we be able to calculate the cost, the minimum cost? Out of all of them, how will we be able to find the minimum cost? The answer is gradient descent. The answer is gradient descent. Now, if you try to understand this term, gradient means slope and descent means going down. So if you have a hill like this, so descent means going down. Ascent means going up. So now what we're going to do is, we are going to plot this cost function. We are going to try to plot this cost function on a graph. Now see, this cost function is not a simple function. It is taking two parameters. So what will happen is, if we will try to draw a graph of this, I will take you to gradient descent. So if I try to draw the graph, it will be a graph on, you will have to analyze this in 3D. So this line will represent the value of the function j theta 0 comma theta 1, this value here. Then since we have theta 0 and theta 1 also, so here I will take another axis like this, and another axis for theta 1 like this. This axis represents theta 0 and this axis represents theta 1. Now remember this in 3D. So for every pair of theta 0 and theta 1, we have the formula to calculate j theta 0 and theta 1. So let's suppose there is a point on this plane, on the plane which is this one, not this. So let's suppose we take any point here, theta 0 and theta 1. Then on this axis, you will have to consider that it is actually coming out of this plane. We will have some value of j theta. And for all of these values, we will try to plot all the points. So when you will try to plot all the points, you will get some graphs like this. Now you can see here on this axis, we have theta 0, we have theta 1, and the value is this. These are the points. There are actually points, and when you connect all those points, you will get a figure like this or like this. It can be anything. So what are these? These are graphs of cost function. So what is the idea behind gradient descent? The idea behind gradient descent is very simple. We try to pick up a point on our graph. For example, I have taken a point A and I calculate, or I take another step, and I take a step which is known as alpha, which is the learning rate, and then I find the gradient or the slope of the cost function. So in 2D you can visualize this as, let's suppose we have a graph like this that goes from, let's say, here, and it goes like this, a distorted graph. So what will happen is we will pick a point, let's say this is our point A, and then we are going to take a step alpha. Remember, we are going to multiply this alpha, which is the learning rate, because we are actually taking some learning steps. So after multiplying alpha, I will get some point here, right? So after multiplying alpha, I will get some other point here, and I will calculate the slope of this line. Now you can see that this algorithm, gradient descent algorithm, will only work when you are going downwards. So after every step, so now you can see it is actually going down. Then we are again going to take a step which is the alpha step, or the learning rate alpha. We are again going to take that step, and then we are going to go down. We will actually see the gradient descent algorithm of how actually this is working. I'm just showing you the intuition behind all of this, and we are going to do this again and again until and unless we reaches a point. And when we take the slope, and the slope is not descent, or I can say ascending, so at that point we are going to stop, and we are going to return this value, and we are going to say that at this value, this is the minimum value, our theta 0 and theta 1 will give me the minimum cost. That's the basic idea behind gradient descent. Now learning rate is important to understand. The choice of learning rate is important. For example, if you take very small steps, let's say you chose that I am going to take very small value of alpha. So let's suppose we are at point A, and you are saying that I'm going to take a very small value of alpha, let's say like this. Now since this value will be so much small, the step will be a lot smaller. So it will take a lot of time for this gradient descent algorithm to reach to the minimum value. And if you try to take alpha too much large, let's say you take 1000 as alpha, let's say. So what this will do is, from this point it will jump to this point, and let's say this is alpha equals to 1000. Then again it is going to take alpha steps. Now alpha step is 1000, so it will overshoot the minimum value, and it will go somewhere here, because this is the alpha rate, because we have multiplied 1000, so it will actually miss this point, so it will overshoot. Then again we are going to take alpha step, which will be this much, so we will reach here. Let's say after alpha step we reach here. Now we know that the slope is what? It is not descending, and we have not reached the minimum yet. Then we are again going to go down. Again we will go here. Let's say this is alpha. Then again we will go here, which is here. So now this overshooting, this is known as overshooting, is actually a big problem. And even taking a value of alpha, which is very small value, it is also a very big problem. In all these cases, these are the problems with the gradient descent. In the next tutorial, we are going to see the gradient descent algorithm. The gradient descent algorithm. So I will just write the expression to find the gradient descent algorithm, and we will explain that this is the working behind of gradient descent. So we try to find the parameters theta 0, theta 1. You can see in here in these graphs, from these graphs you can say B is a minimum point here, and here you can get the minimum point. So you just try to go down, down and down by taking the alpha steps, or the learning rate. You take steps to go down by taking the slope. So since we were taking the slope, and to calculate the slope we will have to take out the derivative of our cost function, and that's the main reason why we have added 2 here. So that's all the idea behind cost function and gradient descent. We will see gradient algorithm, descent algorithm in the next tutorial. So that's all for this tutorial. Thanks for watching. So let's